Dr. Kashif Ali, welcome. Are you around now? Okay. Dr. Kashif from University of Karachi, his oral presentation about the synthesis and evaluation of histidine. So welcome, Dr. Kashif.
Well, thank you so much for such introduction. I am actually not from University of Karachi. I am from Zabis University. And first of all, thank you very much for the organizers for giving me this opportunity to present my research in this prestigious event. The title of my presentation is Synthesis and Evaluation of Histidine-Capped Silver Nanoparticles Loaded with Ciprofloxacin as a potent antibacterial formulation. So the research work is about combating against antimicrobial resistance. And me and my research group is working on this in this domain for a number of years. And I am presenting one of the research that we have recently concluded. And there are the details of the research. So everyone knows that antimicrobial resistance is very alarming. It is actually one of the most devastating problem that probably the medical science is facing and will be facing, but unfortunately it is not that much highlighted. Many of the things, many of the antibiotics are becoming ineffective, and bacteria or the pathogens are getting more and more smart and becoming resistant against many of the antibiotics that are present right now. To overcome this problem, there are many solutions available, but me and my group are actually focusing on nanoparticles. Nanoparticles are actually the particles at the nanoscale between less than 100 nanometers in size. And in this research, we actually work on silver nanoparticles because of their low toxicity and very high affinity. And there are many applications already available of silver nanoparticles in order to address the problem of antimicrobial resistance. The drug that we are working with is ciprofloxacin, which actually belongs to a group of drugs known as fluoroquinolone, and it is actually responsible to stop the DNA replication in bacteria by binding with the DNA gyrase enzyme. So our primary aim is to somehow make ciprofloxacin effective again against those bacteria who have already shown resistance against this antibiotic. So in order to do that, we actually attach silver nanoparticles which are capped with histidine and would like to explore the possibility of making ciprofloxacin effective again. For this research, we use the bacterial strain which are already available in our university. We have a biobank facility available in our university, and we have these cultures available, which are E. coli, Pseudomonas aeruginosa, and S. aureus, and Listeria monocytogenes. So the silver nanoparticles are synthesized by already a published method, which already cited here. We have done the attachment or loading of antibiotic with silver nanoparticles with the reference which is mentioned. And just I'm skipping the details because I wanted to finish in time. I hope you understand. The formation is of the nanoparticles and their capping with histidine and their attachment with ciprofloxacin. All these three things were actually chemically or physically, I should say, confirmed by the techniques of UV visible spectroscopy and FT Fourier transform infrared spectroscopy. And finally, we have done to cross-check the effectivity of the drug. We actually done the antibacterial, antioxidant, and antibiofilm activity in a conventional method, like always done in many of the labs. So For the results, on the left side of the slide, there is a most terrifying image, I must say, where all the four bacteria that I just mentioned are actually showing highly resistance against the drug of ciprofloxacin. And our target is to overcome this resistance that is shown in this picture. So moving to the right, on top, we are having a schematic representation of how silver nanoparticles are actually attached with the histidine. And in the bottom, we have seen that histidine-capped silver nanoparticles are attached with ciprofloxacin to create this molecule of silver nanoparticle, histidine, and ciprofloxacin. So I'm skipping the chemical details just to save the time. Here on the left side, you can actually see the on top we have UV spectra of the three conjugates, and in the bottom we have Fourier transform and FTIR spectra for the same. These spectra are confirmed with the library, which is available, and it is actually the match that we are expecting. So we believe that the things that or the conjugates that we would like to create, we actually successfully created them. On the right side top, you can see the scan electron microscope image of the nanoparticles, and also at the bottom you can see the same. The top one is actually without ciprofloxacin, and the bottom one is when we attach Cipro with the nanoparticles and histidine. Excuse me. So now we have seen some promising results. You can see on top there is a large clear zone of inhibition present in the case of all four bacteria who actually shown resistance against ciprofloxacin. You can see there are four wells, and the well which is labeled as ciprofloxacin, histidine, silver nanoparticles are showing the largest zone of inhibition, while on the same plate with the same culture, ciprofloxacin showing no zone of inhibition. So on this node, actually, you can see on the right side, the which is actually showing the anti-biofilm activity, and just right at the bottom you can see on the top first you can see in the test tubes there is a purple color ring formation, and that ring formation is actually showing biofilm formation. But at the bottom with ciprofloxacin, histidine, silver nanoparticles test tube, that ring is actually disappeared. And just to brief the audience, the formation of biofilm is actually indicated many times that the bacterial strain is actually resistant against many of the antibiotics. So disappearing of the purple ring and the inhibition of biofilm formation is actually the indicator that the bacteria is becoming susceptible again. In the left bottom, you can actually see the antioxidant activity, and here you can see when compared it with the ascorbic acid, which is used as a reference, the same formulation of ciprofloxacin, silver nanoparticles kept with histidine showing very high antioxidant activity. So with that, I reached to my conclusion slide, and it is that we have actually tried to overcome the problem of antimicrobial resistance by actually using not only the silver nanoparticles but also try to make a drug which has become ineffective against many of the bacteria, but just by adding silver nanoparticles to the drug with and stabilize the conjugate with histidine, we actually try to recover the effectivity of the drug and to overcome the problem of antimicrobial resistance. And these are the references that I mentioned in my methodology, and some are more for the information. And I would welcome any questions from the listeners, and thank you very much for your patience listening. Thank you.
Thank you, Dr. Kashif Ali. Thank you for your